Beyond the blueprint, introducing epigenetics. Our DNA, the intricate blueprint of life, holds the code for our existence. It dictates our traits, from the color of our eyes to our susceptibility to certain diseases. But what if I told you that this genetic blueprint is not set in stone? What if our genes could be influenced by the world around us, by the choices we make, and even by the experiences of our ancestors? This is where the fascinating field of epigenetics comes into play. Epigenetics explores the mechanisms that control gene expression, determining which genes are turned on or off without altering the underlying DNA sequence. Imagine a vast library of genes, each containing valuable information. Epigenetics acts like a librarian, deciding which books are accessible and which remain hidden on dusty shelves. These epigenetic changes, influenced by factors like diet, stress, and exposure to toxins, can have profound effects on our health and well-being. They can determine our risk for chronic diseases, shape our behavior, and even influence the traits we pass on to our children and grandchildren. Epigenetics is revolutionizing our understanding of heredity, revealing a dynamic interplay between our genes and the environment. It challenges the traditional view of DNA as a static blueprint, instead portraying it as a canvas upon which our experiences paint their stories. The epigenetic orchestra fine-tuning gene expression. Imagine a grand orchestra, each instrument representing a gene within our cells. The DNA sequence provides the musical notes, but it is the conductor, the epigenetic mechanisms, that determines the volume, tempo, and overall harmony of the symphony. Epigenetics acts as a sophisticated control system, ensuring that the right genes are expressed at the right time and in the right cells. Without this intricate regulation, our cells would be in a state of chaos, unable to perform their specialized functions. Two primary mechanisms orchestrate this epigenetic symphony: DNA methylation and histone modification. These processes act like molecular switches, turning genes on or off by altering the accessibility of DNA to the cellular machinery responsible for gene expression. Just as a conductor guides the musicians to create a harmonious melody, epigenetic modifications ensure the coordinated expression of our genes, allowing for the development, function, and adaptation of our bodies throughout our lives. DNA methylation, a molecular switch for our genes. Imagine a light switch that can dim or brighten a room. DNA methylation, a fundamental epigenetic mechanism, acts in a similar way, modulating the activity of our genes. This process involves the attachment of a methyl group, a simple chemical tag, to specific regions of the DNA molecule. These methyl tags can physically block the binding of proteins required for gene expression, effectively silencing the gene. Think of DNA methylation as placing a sticky note over a light switch, preventing it from being flipped on. This silencing effect is crucial for normal development, ensuring that genes are expressed only when and where they are needed. However, environmental factors like diet, stress, and exposure to toxins can disrupt the delicate balance of DNA methylation, leading to abnormal gene silencing or activation. These epigenetic alterations can have far-reaching consequences for our health, increasing the risk of chronic diseases like cancer and heart disease. Histone modification, shaping the genetic landscape. Imagine DNA as a long, thin thread that must be carefully packaged within the nucleus of every cell. This organizational feat is accomplished by histones, proteins that act like spools, winding up DNA into compact structures called nucleosomes. But histones don't just provide structural support, they also play a crucial role in gene regulation through a process called histone modification. These modifications involve the attachment or removal of chemical tags to the histone proteins themselves, altering the way DNA is packaged and influencing gene accessibility. Imagine adding or removing beads from a necklace, changing its length and drape. Histone modifications similarly alter the structure of chromatin, the complex of DNA and proteins, making genes more or less accessible to the cellular machinery responsible for gene expression. These modifications, influenced by environmental cues, fine-tune gene expression, ensuring that the right genes are active at the right time, allowing cells to respond to their surroundings and carry out their specialized functions. Section 5. The legacy of our past. Inheritance of epigenetic marks. Our genetic inheritance extends beyond the DNA sequence we inherit from our parents. Emerging evidence suggests that epigenetic marks, those molecular switches that control gene activity, can also be passed down through generations. This means that our experiences, both positive and negative, can leave a lasting imprint on our epigenome, potentially influencing the health and traits of our descendants. It's as if our cells possess a memory of our past, a molecular echo of our ancestors' lives. Imagine a family recipe passed down through generations, each generation adding their own twist or variation. Similarly, epigenetic marks can be inherited and modified over time, reflecting the cumulative experiences of our lineage. This transgenerational epigenetic inheritance has profound implications for our understanding of health and disease, suggesting that the legacy of our past can shape the well-being of future generations. Section 6. The Ripple Effect: Transgenerational Epigenetic Inheritance. The impact of our environment and lifestyle choices can extend far beyond our own lifespan, creating ripples that influence the health and well-being of our children, grandchildren, and even future generations yet to be born. Studies on transgenerational epigenetic inheritance have revealed that exposures to environmental toxins, nutritional deficiencies, and even traumatic experiences can leave lasting marks on the epigenome, affecting gene expression patterns in subsequent generations. For instance, research has shown that offspring of individuals who experienced famine during early development may have an increased risk of developing metabolic disorders later in life, suggesting that epigenetic changes induced by nutritional deprivation can be transmitted across generations. These findings highlight the interconnectedness of life and the profound responsibility we have for the well-being of future generations. Our actions today can have a lasting impact on the health and fate of those who come after us. Section 7. Epigenetics and Health: A New Frontier in Disease Prevention. Epigenetics is rapidly changing our understanding of health and disease, revealing how environmental factors can interact with our genes to influence our susceptibility to chronic illnesses. Lifestyle factors like diet, exercise, stress management, and exposure to toxins can leave their mark on our epigenome, altering gene expression patterns and influencing our risk for diseases like cancer, heart disease, diabetes, and even mental health disorders. This emerging field of study holds immense promise for developing novel strategies for disease prevention and treatment. By understanding how environmental factors influence our epigenome, we can make informed choices to promote a healthier life for ourselves and future generations. Epigenetics empowers us to become active participants in our own health destiny, recognizing that our lifestyle choices can shape not only our own well-being, but also the health of generations to come. Section 8. The Power of Choice: Shaping Our Epigenetic Destiny. Our genes are not our destiny. Epigenetics reveals a remarkable level of plasticity in our biology, demonstrating that our genes are not fixed, but rather responsive to the world around us. The choices we make every day, the foods we eat, the amount of exercise we get, the way we manage stress, can influence our epigenome, shaping our health and well-being in profound ways. By embracing a healthy lifestyle, we can create a more favorable epigenetic environment, promoting the expression of beneficial genes and reducing the risk of chronic diseases. We have the power to rewrite our epigenetic code, influencing our own health destiny and that of future generations. Epigenetics offers a message of hope and empowerment. It reminds us that we are not passive bystanders in the face of our genes, but active architects of our own health and the health of generations to come.